number 10, without graphing, state the end behavior for each graph. So without your graph calculator to check you, you have to know even powers and odd powers. So evens, which, even numbers, are either going to be down, down, or up, up, depending on whether they're positive or negative. Obviously, this will be a negative, this will be a positive. So taking that into account, this is an even function, it's positive. I'm sorry, not positive, it's a 4, so it's an even number. It's positive value, so it's going to be up, up for our answer. Odds are either down, up, or up, down. So this is going to be a positive, and it's going to be a negative. Sorry, I got those flopped. But if you think about it, a positive is starting down and going up. A negative is starting up, going down. So it's kind of like the slope rules. If you have a positive slope, it's going upward. It's going to end in the upward direction. So that's how you can remember the odds. If it's a positive function, it's going to end in the upward direction, which means it starts in the downward. All right, so this one is negative, so we're going to consult this example here. So it's going to be starting up and going down like a downhill slope. So that means this one is up, down. Okay, now let's look at number 12. State one possible equation for the graph. So now we're going to look at this graph here. So simply by looking at the graph, we can see there's a root here at 0 and at 3. We see that the direction is up, down. So that tells us, just as a quick review right here, the odds, when it's up, down, that means it's negative. So let's start our function off. We can say f of x equals negative something. We have a triple root now at x equals 0. So that means a triple root is going through looking like an x cubed function, either going up or going down, but we can see it has that curve that is resembles an x cubed. So that's happening right here. So this is a multiplicity of 3. Multiplicity of 3. So we know that there's going to be, at x equals 0, so that's just an x, it's going to have a cubed power on it because it has the shape of a cubed graph. Okay, here at 3, what shape does this look like? This is a parabola. Parabolas are squared, or x squared, I should say. So we're going to show that by saying it, the root x equals 3, so that's going to be x minus 3. There's a power of 2 on that. There's a multiplicity. So this one has a multiplicity of 2. This one had a multiplicity of 3 because it's shaped like a cubed graph. This one has a multiplicity of 2. It's shaped like a squared graph, parabola. If it was going straight through the line like this, if this line continued, and it went through at a 0 here, this would be a multiplicity of 1 because it's a linear function. Just as a little side example. Okay. So our function is going to look, this is an example of what this function looks like. We don't know about any stretch or anything, so we can be for certain that it looks something like this. We know it has a root at 3 that has a multiplicity of 2, and it has a root at 0 that has a multiplicity of 3, and we know because of the end behavior, it starts up and goes down like a downhill, it has to be a negative leading coefficient.